This is the example which is based on principle of superposition. How to solve this example? For this, first we are going to check this beam is in equilibrium or not. Okay. In this example, there are number of forces are acting on this beam, and the distance of all the sections are given, and cross sectional area of this bar is given as 500 mm square, and E for this rod is given as 80 gigapascal. Okay, first step is to check this is in equilibrium or not. Okay, to check this, first find out the forces which are going towards the left and the forces which are going towards the right. This gives the equal values. Now this force is going towards left 100. This force also going towards left is equal to this is going towards right plus this is also going towards right. The summation of this is 130 and summation of this is also 130, means this is in equilibrium, and we can solve this example by using principle of superposition. Okay. In that, the first step is to draw the free body diagram. Now, afterwards, calculate the change in length for each section. And last step is to calculate total. Now, how to calculate this? First, we are going to draw the free body diagram. How to draw the free body diagram? We can extend these lines. Okay. First, take this force at A. Okay. And draw the lines. Take this force which is going towards left. Find the force on another side which is also going away from that side. In this case, this and this are matching, and we can draw it here. This is also going towards which is away from the body. This is also away from the body. This is 100 kilonewton, this is 80 kilonewton. Take the minimum of both values for our calculation. We can write it as 80 kilonewton, and remaining value we can write it on the above side. 80 matches, the work of B is done. Now here 20 is remaining. For that purpose I can redraw here line, and this force also going away from the body. Find another force which is going away from the body. This is also going away from the body. We can extend line up to this. Okay, and we can draw it here. Here 50 kilonewton is there, and here 20 kilonewton is there. Now we are going to take the minimum of the two values. We can write 20 here. Here remaining is 30. Now 20 plus 80 is 100. The work of A is also over. Now here 30 is remaining. That's why I have drawn here one line. The force is towards the surface or towards the line. Now find another force which is towards the surface. Okay. Now here 30 is remaining, and this 30 matches. We can take 30 kilonewton here. This is the free body diagram. Here we can name it as AB, here we can name it as AC, and here we can name it as CD. Now for this section the length is 500. For this section the length is 500 plus 1000, that is nothing but 1500. And for this section the length is 1200. Now second step is to calculate the change in length in each section. Change in length is nothing but PL upon AE. P is 80 kilonewton, means 10 raised to 3. L is nothing but 500 mm divided by area is given as 500 and E is given as 80 gigapascal, which is converted into Newton per mm square. Newton per mm square. Okay. 8 into 10 raised to 3 Newton per mm square. Now we can easily calculate the change in length for AB section. Change in length for AB section. This will give the answer as 1 mm. Give as 1 mm. Okay. Now calculate the change in length for section AC, which is nothing but PL by AE. P is 20 here, 20 into 10 raised to 3. L is 1500 divided by area is given as 500 and E is given as 80 into 10 raised to 3. We can easily calculate this in calculator, which gives the result as 0.75 mm. Now lastly we can calculate the change in length for CD section. PL by AE. P is here 30 kilonewton into 10 raised to 3. L is 1200. Area is 500. E is 18 to 10 raised to 3. We can calculate this in calculator, which will give the result as 0.9 mm. Okay. Now therefore total change in length is equal to change in length for AB section, change in length for AC section, and change in length for CD section. Here the plus minus sign depends upon the nature of the force. Here the nature is tensile, here the nature is tensile, here the nature is compressive. Therefore we can take the tensile forces as positive, this positive, this positive, this positive, this positive, and the compression stresses, this gives the negative value. We can rewrite this as 1 plus 0.75 minus 0.9, which gives the result of change in length for total change in length, which is nothing but 0.85 mm. This is the final answer. Thank you.